Hello children, how are you doing? I hope you all are doing fine, and let's start the new topic. Our new topic for today is force and pressure. So aim to learn. Let's discuss about कि हम आज क्या सीखने जा रहे हैं. We will learn about force, a push or pull, effects of force, pressure, barometer. Forces are due to an interaction, and types of forces, fluid pressure. So let's start the chapter with warm up. In each of the following cases, identify and write if the force is a push or pull. In our day-to-day life, we perform many activities such as opening or closing our doors, squishing a toothpaste tube, picking a book, hitting a ball with a bat, catching a ball, pulling a chair, lifting a box, etc. All these activities require us to apply some kind of force. Force, a push or pull. A force can be defined as a push or a pull exerted over an object that may give energy to the object and cause it to start moving, stop moving, or changes its motion. Example, if you want to open a door, you exert a force on it to cause it move. Increasing your force will make it move faster. If you want to keep the door from opening, you also apply a force on it. This time the force prevents the door from moving, and if you want to change the direction in which the door is moving, you exert a force on it. Forces are due to an interaction. How does the force come into play? For the force to come into play, there should be two interacting objects, one or which the force is applied and the other who applies the force. For example, consider a man standing behind a stationary car. Okay, will the car move due to the mere presence of the person behind it? Certainly not. Now he pushes the car begins to move in the direction of the force, and thus interaction between the car and the man results a force to act between the two. Interaction between the two bodies may or may not involve a direct physical contact. Resultant force, the total force applied on the heavy box is called resultant force. When two forces applied on a body act in the same direction, then the total force acting on the body will be equal to the sum of two forces and the direction will remain same. But when two forces act at the same point in opposite directions, then the resultant force will be equal to the difference of the forces and direction will be along the greater force. This can be explained with the help of an example of a game of tug of war in which two teams pull at a rope in opposite directions. The members of both the teams pull the rope in their direction. The team that applies a greater force wins the game. Effects of force. When a force is applied of an object, it may have the following effects on it. Change in the state of rest or motion. A force can make a body move and can stop a moving body. A football moves on applying a force on it. By a kick, we can stop it by applying a force in the opposite direction. Changing in speed. When change in speed, when a force is applied on a moving object, it can change the speed of a moving object. If a boy pushes a moving cyclist in its direction, its speed increases, but if the boy pulls the cycle back, the speed of the cyclist will decrease. You can see in the picture. Change in direction. Force can change the direction of a moving object. A football player kicks the moving football to change its direction. During the game of cricket, when the moving ball is hit by a bat, it changes its direction. Change in shape. A force can change the shape of an object. When force is applied to a non-rigid body such as a toothpaste tube, tomato, clay, wax, etc., it causes a change either in the shape or size of that body. In other words, the force causes deformation. Types of forces. Forces may be classified as contract forces, non-contract forces. Can you push or pull a chair without touching it? No. You should have physical contact with the chair in order to push or pull it. A force acting between the two bodies that requires a physical contact between them is called a contact force. Muscular force, frictional force and mechanical force are examples of contact forces. Now, consider a body falling towards the earth. We know that it is falling down because of the gravitational force of the earth which is pulling the body down. Is there any physical contact between the earth and the body? A force acting between the two bodies that does not require any physical contact with them is called non-contact force. Contact forces, now there are mainly three types of contact forces. One is muscular force. This force exerted by the muscles of a human or animal's body is called muscular force. We use our muscular force during running, walking, kicking and lifting certain objects. Frictional force, when we stop paddling a bicycle, it gradually slows down and finally comes to rest. Similarly, a boat comes to rest if we stop rowing, अगर उसका रो में लगाना. Yes, if we stop rowing. In the above situations, there is a force responsible for slowing down moving objects or preventing them from moving. This force opposes the motion of the moving object and is called friction and frictional force, right? Friction is a contact force as it arises due to contact between surfaces. The force of friction is responsible for the wear and tear of moving parts of machines. Friction also makes it possible for automobile vehicles to move on roads, since in the absence of friction, the wheels would keep on turning without the vehicle moving forward. Science fact: in 1687, Sir Isaac Newton published the universal law of gravitation. Sports shoes have grooves and tires are treated to increase friction and give a better grip on the ground. It is extremely difficult to walk on a wet or smooth surface since the frictional force is reduced by water or smoothness of a surface. Mechanical force: the force exerted by a machine is called mechanical force. This force needs an external source of energy for its protection. For example, the energy of diesel or petrol produces the force which runs the engine of automobiles and various other machines. Similarly, the energy of wind produces the force that makes a sailboat move, and these are mechanical forces. Non-contact forces: there are mainly three types of non-contact forces. One is gravitational force. Gravitational force is basically the force with which the earth pulls other objects towards it, is called force of gravity. It is a natural force of attraction. For example, when a ball is thrown up, it falls to the ground. It is gravity for each which brings it to the ground. Similarly, water from a tap always flows downwards due to the force of gravity of the earth. Gravity is not a property of the earth alone. In fact, every object, whether small or large, exerts a force on every other object. This force is known as gravitational force, and gravitational force is the force of attraction between two bodies placed at a distance in the universe. It is one of the fundamental forces in the universe. The magnitude of gravitational force depends upon the masses of the two bodies and the distance between them. Gravity acts on objects from a distance without touching each other, and therefore the gravitational force or gravity is an example of non-contact forces. Magnetic force: the force of attraction or repulsion exerted by magnets is called magnetic force. A magnet attracts iron filings, nails and other objects made of iron, steel, nickel and cobalt. This activity, now let's do this, aim to observe the forces acting between magnets, and materials required are pairs of bar magnets, pencils of wooden rollers. Method is that take a pair of bar magnets, place the longer side of one of the magnets over three pencils or wooden rollers as shown in the picture. In the first case, bring one end of the other magnet near the end of the magnet placed on the pencils. Make sure the two magnets do not touch each other. Now, note what happens to the magnet placed on the rollers every time another magnet is brought near it. In the second case, bring the other end of the magnet near the same end of the magnet placed on the pencils. Note what happens. Observation. In the first case, the two magnets repel each other, and in the second case, they attract each other. Conclusion. This activity proves that magnets exhibit attraction and repulsion properties. Now, electrostatic force, the force between the two objects as a result of the interaction between the charges on them is termed as electrostatic force. This force occurs even when the bodies are not in contact. For example, if you rub a comb on dry hair and bring it near tiny pieces of paper without touching them, the paper gets attracted due to the electrostatic force of attraction exerted by the comb, and therefore electrostatic force is also an example of non-contact force. Do you know electrostatic force is also used to control air pollution by separating solid pollutant particles from smoke given out from factories. Activity time. Aim to study an electrostatic force. Materials required is a plastic ruler and tiny bits of paper. Method. Take a plastic ruler from your pencil box. Rub it vigorously on your hair. Make sure your hairs are dry. Bring the rubbed end near some tiny bits of paper. Observation. The tiny bits of paper get attracted to the plastic ruler. Conclusion. The ruler acquires an electric charge while rubbing. This charge can exert a force called electrostatic force. Unit of force. In the SI system, the standard units of length, mass and time are meter, kilogram and second respectively. In this system, the standard unit of force is Newton N. In the CGS system, the unit of force is dyne, and 1 N, where the 1 N is equal to 10⁵ dynes. Now let's talk about pressure. The force acting on a unit area of surface is called pressure. There are mainly many physical situations where pressure is not most important. Pressure is a measure of the effectiveness of a force. It takes into account the force and the area over which it acts. Pressure is force per unit area applied to an object in a direction perpendicular to the surface. Pressure is equal to perpendicular force by area, F by A. Notice that if the force increases, the pressure increases. If the area over which the force acts decreases, the pressure decreases. Examples of pressure in everyday life. The drawing pin is broad based towards the thumb side and pointed towards the other hand. This decreases the area of contact and the pressure exerted by the thumb increases. Thus, piercing becomes easier. Foundations of high-rise buildings are kept broad and wide so that they exert less pressure on the ground and do not sink in due to the extremely high pressure of the building. The skiers used flat and long skis to slide on snow. This is because due to larger area, pressure exerted on the snow will be lesser and skier can easily slide without sinking into the snow. The rear wheels of tractor are made broader. The broad tires reduce the pressure on the soil and the tractor could move easily through the field. Camel can walk through desert sandy soil easily as compared to other animals such as horse, donkey, etc. This is because camel has broader feet. School bags and shopping bags have broad straps with which they are carried. Narrow string-like straps cause severe pain because the weight of the bag acts on a small area and this increases the pressure considerably. Do you know a sharp knife is more effective in cutting a fruit than a blunt knife because the area of contact in the case of sharp knife is lesser than that of blunt knife. Porters wear turbans and when they have to carry heavy loads on their heads to increase the area of contact, this reduces the pressure on the head and because the pressure to reduce the pressure they carry this on the head. War tanks move to Caterpillar tracks which are broad chain-like covers on the wheels. This causes a large increases in the area of contact with the ground. Due to this, the pressure on the ground reduces so much that tanks can even move on soft, wet ground without sinking. Science fact: manometer is an instrument used to measure pressure of the pipelines, gas, water, liquid, etc. Units of pressures are in SI system. Force is measured in Newton and area is measured in square. Therefore, the unit of pressure is Newton per meter square, and this unit is known as Pascal. Thus, 1 Pascal is 1 Newton meter, and or 1 PA is 1 m minus 2. Simple calculation based on pressure. Example: a girl of mass 50 kilograms standing on pencil heels, each of area of cross section of 1 centimeter square. Find the force exerted by the girl. Gravity 10 meters square. For girl, mass of the girl is 50 kilogram. Force exerted by the girl 50 kilogram into 10 meters squared and 500 N. Area of cross sections of two wheels is equal to 2 into 1 centimeter square is equal to 2 by 1 by 10,000 meters square. Pressure exerted by the girl F oblique A, 500 N into 10,000 by 2, 25 lakh. Applications of pressure. Some useful applications of pressure are given below. Buildings and dams are made broader near their foundations. This makes their overall weight act over a large area and reduces pressure on the ground. Bags and suitcases are provided with broad handles because small pressure is exerted on the hand while carrying them. The railway tracks are laid on the large sized wooden, iron or cement sleepers. This is done so that the thrust due to weight of train is separate over a large area. Due to this, there is a less pressure of the train on the ground and railway line does not sink into the ground. Buses and trucks generally have doubles wheels at the back, and these increase the area over which their weight acts and hence reduce their pressure on the ground. Fluid pressure. A fluid is a substance that can flow. All liquids and gases are fluids, and this pressure, the pressure exerted by a fluid is called fluid pressure. A fluid contained in a vessel exerts pressure at all points in all the directions. As the molecules in fluids can move up, down and sideways, they continuously collide with each other and with sides of the container. While doing so, they exert pressure on the walls of the container from all directions. This gives rise to the fluid pressure. Pressure exerted by a liquid. You know that a liquid has mass and weight due to the force of gravity. This weight of force acts downwards on the base of container which holds the liquid. There are certain characteristics of pressure exerted by a liquid, and these are as follows. Pressure exerted by liquid at the bottom of the container depends on the height of its column. Liquid exerts pressure on the walls of the container. Liquid exerts equal pressure at the same depth. The pressure exerted by liquid increases with depth. The following activities will give you a better idea of the pressure exerted by a liquid. Now let's do one activity. Activity aim is to show the pressure of the liquid increases with depth. Procedure is to take the plastic bottle and make 3 holes in it at different heights. Fill the bottle with water and allow water to flow into it continuously from a tap, and notice the force with which water comes out of the holes. Observation: you will find that water comes out with greater force from the holes at greater depth, and water from the bottommost hole with spout out farthest from the bottle. Conclusion: this shows that the pressure in a liquid increases with the increasing depth. Activity time. Aim to show that a liquid exerts pressure on the walls of the container. Procedure is to take a waste plastic bottle and make a hole at its bottom. Insert a tube in the hole horizontally to make with a tap-like opening at the side. Tie a balloon to the opening and fill it with water. What do you observe? Observation: you will notice that the balloon bulges outwards. Conclusion: this shows that liquids exerts pressure not only on the base of the container but also sideways on the walls of the container. Measurement of liquid pressure. The instrument used for measuring the pressure of fluids is called a pressure gauge, and the simplest type of pressure gauge is the U-tube manometer. It consists of U-shaped glass tube filled with a liquid. It is used to measure the difference in pressure at the two ends of apparatus. One end of the tube opens into container filled with the liquid and other end of the tube opens into air. The difference is liquid level. In U-tube is a measure of the pressure applied by water. Pressure exerted by a gas. All gases exert pressure on the bottom, the walls and the top of their container. The air present in the atmosphere exerts pressure on all the bodies. For example, air in the bicycle tube comes out when it has a puncture. We cannot inflate the balloon with which has holes, and because there exerts pressure in all directions. Atmospheric pressure. Earth is surrounded by air and this covering of air is known as atmosphere. The atmospheric air exists to a height of about 10,000 km, but beyond the 100 km the air is very thin. Air exerts a force on the surface of the earth called the atmospheric pressure. Barometer. Atmospheric pressure measurement are important to meteorologists for weather forecasts. The unit of pressure used for meteorological purpose is called the bar. A bar is a CGS unit of pressure and equals Pascal of or 1 bar. 1 bar is equal to 1 m/m square. A barometer is a device used for measuring the atmospheric pressure. Uses of atmospheric pressure. Atmospheric pressure is used in many of the things that we do. For example, when we drink water with a straw while sucking, our lungs expand and air in the drinking straw goes into them. Air pressure in the straw decreases and the atmospheric pressure acting on the surface of water then forces the water to move up inside the straw and into our mouth. In the same way, atmospheric pressure forces a liquid to move into a syringe when its plunger is withdrawn. A good quality rubber sucker looks like a small rubber cup. When you press it hardly over any smooth surface, it sticks to it and is very difficult to remove. Why? It is because when we press the sucker against the smooth surface, a large amount of air between the sucker and the surface is expelled out. Thus, the pressure of air outside the sucker holds it to the smooth surface. Let us do. You have to write T for true and F for false. Yes, children, once again opportunity to just check the recall the chapter's information. Revision time, all the activities which involve the movement of people, of things, or things require force. Force could be push or a pull. A force arises due to the interaction between two objects. Forces may be classified as contact forces or non-contact forces. The SI unit of force is Newton. The unit Newton is denoted by the letter N. The force acting on a unit area of surface is called pressure. The force exerted by the atmosphere on unit area is called atmospheric pressure. A barometer is a device used for measuring the atmospheric pressure. It's your turn now to do practice through exercises. As usual, darken the circle with correct option in the homework sheet. And you have fill in the blanks, complete them with the correct word, state T for true, F for false, check the statement, and accordingly you mention T and F. Very short and long answer, very short in 3-4 sentences, short will be in 5-6 sentences, and long answers will be in detail, should be answered in notebook. Activity time. Do this activity by taking 4 to 5 plastic bottles of different shapes and sizes, join them together with small pieces of glass or rubber tube. Keep this arrangement on a level surface. Now pour water in any of the bottles. Note whether the bottle in which water is poured gets filled first or all the bottles gets filled up simultaneously. Note the level of water in all the bottles from time to time and try to explain your observations. Homework is visit a petrol pump, talk to the person who fills air in the tire and ask him to show you the pressure gauge and he uses. Find out how much pressure is needed for each vehicle such as scooter, car, truck, etc. And while doing this, have fun, children, enjoy.